Hello everyone. Today I'm going to talk about domains and Grasshopper and how we use them, how do we manipulate them, and possibly I'm going to make some examples and either in this video or the next that how domains could be actually extremely useful in different applications. So, getting started with domains, you can find them under this tab once you have the Grasshopper launched. Math tab. So if you just click on math and then you'll see the first drop down menu is called domain. So here we can actually find all domains, components related to domains, how we create them, how we deconstruct them, basically meaning that we extract the information within a domain. How do we get the bounds, minimum to the maximum numbers from the start to the end? And how we can, for example, create consecutive domains within existing domains or through a series of numbers, a list of numbers. How can we divide domains and or finding them within another list, and to check, for example, if numbers are included in domains or not, and a specific number that we're looking for, is it within a domain or not. And if, for example, we want to remap numbers from one domain source to another different target domain, how we can do that, the process is called remapping. And the other concepts here that are presented as 2D or two-dimensional domains that represents the UV parameters of the surfaces, and how can we create or basically extract information from U and V values of a surface within a domain range, and how we can, for example, use the two-dimensional domains to subdivide a surface, a given surface, into multiple equal segments. So, getting started, um, the first component I want to just click and drag it in the canvas. And if I just, hold my mouse pointer, then you can see that it just says construct domain. It needs A input and B. A is the start of the domain that we want to make, and B is the end. So by default, this component has 0 to 1 because the default number given to A is 0, and the default number given to B is 1. So for example, well, I'm going to create a panel and visualize it here, 0 to 1. And if I want to have a domain from 0.02 until, for example, 264, just two completely random numbers came to my mind, then you can see, for example, yeah, here is the domain. It's very simple, right? And the second component is the construct domain, which basically means if I have an already existing domain here, the output I can give it as input to the construct domain component, and then I can extract data as start and the end of the domain, right? Separately. So basically, this is a reverse process of what we did here, giving in the start and the end numbers as values to A and B, A and B. And then here we can actually deconstruct them and extract the values of start and the end again. So if I just connect it, then I can see I have one panel as the start, and then end will be the second number that I give here. So if I just change it, then you see it's relatively, of course, changing. So this is a construct and deconstruct domain. Maybe it's also more helpful if I just switch to draw full names of the components, and you can see with the names. And if I want to start with explaining the third component that we have in the drop-down menu from domain, it's called bounds. Bounds, basically, you can give it a multiple number input. It can be a list of, for example, coordinates. It could be a list of numbers representing length or size of an object. And then it gives us the bounding domain, which means it tells us the list starts from which number as the smallest, the minimum, and ends up to which number as the maximum value of the domain. So in order to see how it is, I'm going to make an example. For example, I'll just make a series of numbers, and I want to start my series from this value, for example, and I need for example 0.5 as the stepping value, and I want this series to go for 99 times. So then I have a series, and this is just a list of numbers, and if I give this list of numbers to the component bound, then the outcome would be from 0.03, which was the start, of course, the minimum number, to the maximum number, which here it says is 49.0.03, which would be the result if you have this type of series of number. And yeah, if you also check the output directly from the series, it starts from that minimum number, goes on until the maximum number. The next component in the list that I want to explain is called consecutive domains. And what it does basically is that you want to create subdomains within a given list of numbers. For example, I can again use the series that I created here before. I brought down a number to 5 so that we have 5 elements in the list, so it will be easier to read. And I want to give that as the input for the numbers here. So then we have an option called additive. Basically what it does is that it will add every single number in the list from, for example, the first one. It gets added to the second one, and then gets added up to the third, to the fourth, until the end, and then it creates domains from them. So by default, this option additive is true. It is a Boolean, so you can make it either true or false by giving it an option of a Boolean toggle. So I'm going to just grab a toggle from Canvas. It is set to false. I want to try out with false first. So I want to check the output. What would be the domains that it creates for me? It's very simple. It starts from 0.1, which was the start of the series, and it creates us 0.1 to 0.6 because my list is adding up, 0.5 as the steps, and then the next one 0.6 to 1.1, 1.1 to 1.6, and then 1.6 to 2.1. These are all domains that it created for me. If I want to have more domains, I can actually have more numbers to the cap of my number series, and then I can see that it creates, for example, again, domains within those numbers. Now, I want to check what would be the difference if I just want to switch this from false to true. What it does, it activates the option of adding the numbers. So it would just take the first one and adding it up to the second value in the list, series list, and then I will end up with having the first row of the domain as 0.1 to 0.7, and from there you will see that every number in the list that it's being used as creating subdomains is being added, 0.7 to 1.8, for example, and so on. It's actually quite interesting and very useful, this component, and also very clear how it works. So we go to the next component in the domain list. I want to grab divide domain and explain divide domain here. It's very clear, as the name of the component says, divide domain. It will subdivide a given domain for us into smaller ones. So if I already have a domain which I'm going to use this one, the bound from the series, give it as an input, and I want to subdivide my domain into 5 smaller domains. And I can grab this panel here and connect it to check, read the data. It tells me that my domain divided into 5 subdomains will be from 0.1 to 1, from 1 to 1.9, 1.9 to 2.8. And if I want to, for example, increase that subdivision, then I just have to add to that slider number. And then it just does the same for me and so on. So on the list of the domain components that I want to explain is find domain. Here you can find it. I drag it into canvas. And if I just hold my mouse pointer on the component, it explains the function of this component, which is finding the first domain that includes the value, specified value in here, which is a number, and it will give you the index of that specific domain that the number exists within. And if you want to, for example, find the closest domain to that index within that number, it would also give you the neighbor, which is the closest other domains that are to that index. So I'm gonna go with the example here. I'll just use the previous example that was made with the subdivide domain. We have 5 domains here. I drag another panel here to just connect it so we can have the domains in front of us. Also, I'll just give that as an input to find domain. Then I want to look for example, number 0.5 and see which index it would give us. It should be index number 0 because 0.5 exists within the first domain, index number 0. And for example, if I want to change it to number 1.9 or for example 1.8, then it would give me the second line here, which is index number 1. So it means that 1.8 is a number within the second domain. So it's quite clear actually. I want to start explaining is about includes. It's another component that tests if a numeric value or a number exists within a set of domains. It works very simple and straightforward, and you just have to give the domains as input here. For example, again, the same example domains, and then you have to specify which number you're looking for, and it would test and it would tell you if that number is within this domain or not. For example, number 0.5 again as the value. It gives output as a list of Boolean outputs. For example, it gives me true, false, false. That means that the number that we have given is existing within the first domain, but does not exist within the other domains from 1, 2, 3, 4. And after this, there will be remap numbers, which is also very useful and commonly used in working with domains and creating different, for example, value manipulations, especially when you want to work with distance of points, that you want to take the value as a list of numbers and translate that into another parameter that you can control for movement or resizing or scaling up and down. Therefore, remapping becomes very, very useful in these type of operations. So I'm going to explain it to you. This is very important, actually, component. How it works is that you give it a list of value that you want to remap, and then the source domain of that list, which you can extract from the same value list, and you tell it, I want to change that or remap that into the new target domain. So you can multiply a value of the target to that source and then get the mapped or the newly remapped values out. So as an example, I'm going to create a series of numbers. They're from 0 to 9. It's a 10-step number series as the values. The source target, I'm going to just use bounds to extract what is the domain of the source domain. Sorry, it will be from 0 to 9. And my target, I want to create a domain and then specify a new target. So I'll go construct domain. The start should be, for example, any number like 5, and the end, it could be 16. So this will be the new target domain that I want these values to be remapped. And if I check the remapped output, you would see that my first value should start from number 5 and then goes on until it reaches 16. And in between, there are all the other steps that it should take. And I can also remap this into a different domain easily. Okay, so here, these are all the numerical domains that you can use in Grasshopper to create and extract the data from different domains, subdivide them, and remap them. But here we have also a different concept. It's called two-dimensional domains. It's a domain within a surface. It's defined within a surface. And a surface in Rhino or Grasshopper is made by two parameters, which are mainly u and v, described as u and v. And u, for example, is like x in the world coordinate system of Rhino, and v could be like y in the coordinate system. So a surface has also both dimensions. And the two-dimensional domain is giving us from where the v to start of the v to the end of the v and start of the u to the end of the u will be described within a two-dimensional value that we can give into surface or extract from a surface. So as an example, if I want to construct a domain, it would be 0 to 1, for example, as default here. For u and also for v. So I already have a domain that I can give as an input to a surface, and I can also use specified numbers for the start and the end of those domains for u and v separately here and get the same type of output. And the other two components are deconstructing the two-dimensional domain, and it does just a reversed process. If I already have one domain and I give it to deconstruct, it will give me what is the minimum, which was already by default 0, what is the maximum, and the same. And this becomes also more understandable, especially when we want to use the two-dimensional domains to deal with, for example, surface operation on a surface. Like we want to subdivide a surface, which this component here, divide to domain, but the two-dimensional type works. Then you have a specified 2D domain, and you can say, I want within this surface domain, I want a new subdivision for u and v. So this works better if I actually make this example with a surface. Imagine that I want to subdivide my surface, for example. I make a new surface in Rhino. I assign that surface into Grasshopper. And I want to subdivide the surface based on a given u and v value. So if I just connect the surface to domain, it already extracts what is the domain of this surface, v and u. And I have to subdivide it using iso trim. Iso trim is the function that subdivides the surface. So I give my surface, and then I have to give it what type of domains, two-dimensional domains, I want it to be subdivision to, based on. It would subdivide my surface into 10 by 10, because here it's already by default number 10. I'm gonna preview off my main surface. I can change this number into, for example, 2 or 1 by 10. So then I would have 10 stripes in the V direction. Or I can do the same in the opposite way. And each of these could be later selected separately if I want to operate, for example, on the first one, a different function or something.